let us now discuss about the pumping lemma for regular languages. Basically, we'll use this pumping lemma to prove that a language is not regular. Okay, for suppose let us take the alphabet L, which is a representation of language. So let L be a regular language. Okay, and there will be a constant N such that for every string Z belongs to L. Z is nothing but a string, input string. Okay, Z belongs to L with det of Z greater than or equals to N. Modulus of Z, I meant. The string Z can be divided into three parts. Z is equals to U, V, W satisfying. Basically, we'll be having these three conditions to prove that it is a regular language. But what are we doing here? We want to prove a language is not regular. So if any of these three condition fails, then we can say that the given language is not regular. Okay, so the first one is modulus of uv less than or equals to n, modulus of v greater than or equals to n. For all I greater than or equals to 0, the string u v par I w belongs to L, which is nothing but here we are going to repeat v multiple times and check if it still exists in the language. Also, n means pumping length. I mean, we'll be giving a string, right? The length of that string is nothing but n. Here L is equals to a par n, b par n, where n is greater than or equals to n. We have to prove that this given language is not regular. First, what we'll be assuming? We'll be assuming L as a regular language. Substitute n value as 1. What will we get? A, B. Substitute n is equals to 2. We'll get A, B, B. Substitute n is equals to 3. We'll get A, B, B, B. Right? Let us take n is equals to 4. We can take it whatever we want. As they gave n is greater than or equals to 1, we can take n is equals to 1, 2, 3, 4. But we need to make sure that the string we take should be greater than or length of the string we take should be greater than or equals to n. For suppose we took the z as a, b, b. I mean, we can take anything from here. I took z is equals to a, b, b. What is my length of the string? It is 4. So I have to take n value greater than or equals to 4 because det of z should be greater than or equals to 4. This is in our hand. N value and z value is in our hand. We can take anything we want from these. Okay. So what the length of the z is 4. 4 is greater than or equals to 4. True. Let us now check the remaining conditions. What we told, the z is divided into three parts, that is u, v, w. We take one character for u, one character for w and two characters for v. Now let us check if length of uv is less than or equals to n. That is the first condition, right? Length of uv less than or equals to n. What is the length of uv? 1, 2, 3. 3 is less than or equals to 4, right? So it is true. The first condition is satisfied. The second condition is that we have to check if length of v greater than or equals to 1. What is the length of v? It is 2. 2 is greater than or equals to 1. So the given this condition is also true. Now let us check the third condition, that is for all I greater than or equals to 0, u, v par I, w belongs to L. Now let us check. U, v par I, w belongs to L, right? Let us take I value as 0. So what we will be getting? A, b power 0, b. Anything power 0 is 1, right? So what will we get the output as ab? See, ab. Is ab belonging to the language? Yes, ab exists in language. So it is true. Now let us take v par 1, which is nothing but ab par 1 into b. We will be getting a, b, b. This also belongs to our language. It exists in our language. So true. Now let's take v par 2. ab whole par 2 would be ab, right? So ab, b. Does it exist in our language? No, it doesn't exist. This condition failed. So it means a contradiction occurred and the given language is not regular. So using these three conditions, we have proved that our language is not regular. Thank you.